Good afternoon. My name is Steve Kendricks. With me today will be George. We are here to present a session today for you on building developer experience with the Model Context Protocol. So if you aren't familiar with MCPs, you're going to get a great introduction as well as how to use MCPs in your daily work with our container services, the Elastic Container Service and the Elastic Kubernetes Service. We're going to go through a few things. We're going to go through, generally speaking, how GenAI agents and LLMs have evolved and why we got to a point where MCPs are so useful. We'll give you an introduction to MCP, just a little bit as a refresher for exactly how we at Amazon tend to think about these things, and particularly why container services benefit from using MCPs. And we'll talk in detail about the ECS and EKS MCP servers that we have released for your consumption today. Okay, and then we'll have a demo talking about, just demonstrating about what you can do today using these MCP servers, both in the console and through your IDE of choice, such as Kiro. So let's talk about a little bit about MCP, the Model Context Protocol. Let's talk about overall how we got here. And again, this is going to be a very fundamental introduction to LLM. But again, I want to cover some of the fundamental constraints so that you understand exactly why it is that we built what we did and how we went about building it. So let's talk about, let's imagine I am a grandmother trying to buy children's gifts for my grandkids. Right? That is my fundamental task. And I have heard all about these AI assistants, which are supposed to help me with tasks like this. Right? And so I have an AI assistant, I have an LLM, maybe I think those are exactly the same thing, right? I don't really necessarily know. All I know is that I can ask questions, right? So here we go, we ask what is AWS, or maybe I say, hey, what are some great kids' gifts ideas for Christmas, right? And of course that interface, whatever it is that I am using, is going to come back to me and say, okay, here's the answer that I have for you, right? It's perfect, it is exactly what we need. Here's a limitation. Right? Let's get a little bit more specific. So I am a little bit more used to using these agents. I've used them for quite some time. So I want to go beyond just saying, what are some great gift ideas for kids? And I move on to, what are the most popular gifts this year? Or what is the must-have children's toy to be used this year? My kids are super into Bluey, for example, or to other different toys. Different kids have different needs, so there's lots of different, maybe I want to use the different STEM. I want to have the best STEM toys for this year. And so, of course, the agent will come back, and without anything in between, it will say, well, I don't really have access to current data in a basic case scenario, and maybe it'll just say, well, I'm going to give you an answer, and maybe I don't know that answer isn't fully correct. Of course, there's other limitations when we try and make agents do specific skills. Of course, if I want to actually do something with the agent, I want the agent to give me specific data, not just about the world itself, but maybe say, go look at my Amazon purchase history and tell me what I bought. Of course, the agent doesn't have access to that information. Or if I want the agent to do something like, say, specifically, I want it to purchase something on my behalf, of course, without anything intermediating the agent and allowing the agent to take that action, it's not going to be able to do that, right? And so, of course, here we have a message where somebody's tried to fix a bug in the code, and the LLM, of course, says, I can't do that. LLMs, of course, you know, as we have played around, those of you who have played around with the LLMs to at least some degree, are only as good as the specific context as we give them and they are allowed to access. Okay? So let's summarize the limitation. We have two fundamental problems. We have an input problem and we have an output problem. LLMs do not understand and they don't know what they don't know because, of course, LLMs are trained on a point in time and they don't know anything that exists in the world outside of when they were trained. Now, you could sit there providing that context in exquisite detail, and this is what many of us did when the LLMs first became popular. We just said things like, assume that the world is this way, right? Assume that the world in the last 6 months has done this, and then it would do a decent job, but that got tiring, and often it would get it wrong, or it would even say, well, I can't assume that because, it's not in my training data or whatever. So then we came up with many different ways to try and address this workflow. So here is one. Especially RAG became popular shortly after LLMs became big. And RAGs were providing a way to give the agent context through knowledge bases. So instead of us just accessing the information directly from the model's training, what would happen is that AI assistant would take its prompt. So say, for example, what is the most popular STEM gift for kids this holiday season? And it would then access that knowledge base first and inject that context into the prompt for the user on the user's behalf. Right? And so it would go look up the RAG and it would go look up the knowledge base, and it would pull that information into the prompt, which would then be fed to the LLM, right? And then we would get a response. There are some limitations with this, of course, because the knowledge base has to be maintained by somebody. It has to be updated. It is only as good as the context that is provided into the knowledge base. And of course, there are limitations about how much we can do. Context windows became very, very large as prompts became larger and larger as the knowledge base information was injected. In many cases, the entire thing was injected into the prompt for the user's behalf. So there's other ways. There's other ways to do dynamic retrieval and dynamic context. And this is where the introduction of things called tools came about, right? Where the AI assistant can actually provide an action for you. The most common way to understand a tool would be something like web search, right? Web search is an extremely powerful tool. So of course we go and we enter the prompt, right? Then the prompt comes and the tool description goes to the LLM. So the LLM says, okay, I know what I need to do, right? And there's a mechanism so for that LLM to interact with the agent, call the tool. In this case, we're going to go search the internet for what the best STEM gifts are so that I can make my child happy. Right? And then we get the tool result, and the LLM consolidates that information and provides it back to the user. Okay? So we seem to have solved this problem, at least for simple use cases. The problem comes when we are dealing with more complex use cases. So for example, if I'm an agent, right, and of course moving beyond just the Christmas gift idea, let's say that we have 3 different things that we need to have. We need the agent to be able to access a database. The agent has to access source code repository so it knows if anything has changed. The agent maybe needs to be populating a CRM. This, in the previous world, that would mean that if I wanted to do that, if I wanted to achieve all these outcomes, I would have to create my own integrations, specifically teaching and training my agent to access these different systems. I would have to train and build some kind of mechanism and give it the correct APIs and give it the correct way to say, this is how you use this tool. And it would be all very, very custom. And if I wanted to switch that out or share it with a colleague, we would have to work through all of these limitations. It wasn't repeatable. Of course, so that is just giving you a summary of some of the problems that we have for model-tool interactions. Right? This is an end-to-M problem. Right? Every model-to-tool connection required custom engineering, lack of standardized context sharing, and stale knowledge over time. Because again, the fundamental problem here being, unless the agent was consistently calling and expending a bunch of tokens and knowing how and when to acquire new knowledge, very often it was still cut off from real-time data. And of course, the model is inherently restricted just by the nature of its development from new data sources. Okay? So this is where the MCP came from, the Model Context Protocol. It was introduced by Anthropic. Model Context Protocol is an open standard for integration between AI apps and agents that use tools and data sources. So APIs are especially, if you think about it like standardize how web backends work, MCP is effectively a similar way to think about how AI should be interacting with tools as well. So think about it this way. It's not necessarily 100% accurate, but it is useful as a way to think about how these tools interact. Okay, so with MCP, we can achieve standardized integration. And I'll explain a little bit about what MCP is and how it achieves this, and then we'll explain about how our container services have used these tools to provide good results to you. So, of course, we have different terminology when we start talking about MCPs. We have the MCP host, which hosts MCP clients. If you think about an MCP client, that is just simply the thing that the MCP server is running on, especially if we're talking about a local MCP server installation. But we have we have an MCP server for our database. We have an MCP server for maybe Git. We have an MCP server for our CRM. And what that means is that the database host, the source code report, generally speaking, own and maintain that MCP. And the things on the left have a standard way to interact with external sources, such that if we wanted to maybe replace our CRM system, we could do that easily without having to recalibrate everything on the left side. So that is effectively how MCP operates. Again, here are the core components of an MCP server. We have the MCP client, which I explained what that is. Just the thing that is running the MCP is actually acting as, usually it's your agent, right? Kiro would be acting as an MCP client. And then the MCP server. The MCP server has three components. It has tools, which is the most common thing that most people think about when they think of MCP servers. We have resources, and we have prompts. So I'll explain what each of these are in just a 50,000-foot detail. So an MCP tool is what we call model controlled. The LLM is controlling the use of the tool through the MCP server. A tool is basically a function of how the model works. So if you think about back to my example of trying to purchase, right, having my agent purchase or just help me in my journey of purchasing a Christmas gift, one tool might be Christmas gift price lookup, right? Price lookup for different types of Christmas gifts or different type of toys or things like that, right? It might be web search. It might be something very specific, something very actionable, right? That's usually a tool. Other ways in your specific use case might be retrieving data, searching for a message, or maybe update a record. There's other types of things. Again, most people are very familiar with MCP tools. There are other types of things that MCP use, or other types of categories that MCP use. MCP resources, they are application controlled. Your application, the thing that is actually trying to run, maybe your service, maybe your web service, maybe your database, that is controlled by the application. And what that is effectively things that used to be your knowledge base. So your files, your database records. Right? My history and the context that is important to me when I have purchased things in the past. So maybe my purchase history might be an example of a resource. Prompts. Now, prompts is a very interesting one because we usually think of prompts as the thing that we put into the agent, right? That's what we think of a prompt. In MCP, it's effectively the same thing, but MCP prompt is a specific capability that allows the user to define their MCP request and response. So think about it this way. Maybe if I own the MCP, I might say, here is a specific prompt which I know is going to provide very good resources. The user has the ability to discover those prompts within my MCP and then use that prompt, right, and say, okay, great, this is the prompt that the MCP has suggested that I use. But of course, I can modify that prompt. I can change it however I want. I can augment it, and I can add things onto it. So those are the three different types of resources that MCP server has. Now, let's talk in detail. So I talked overall, right? That was a very rapid rush into how MCP, the history of why Model Context Protocol is needed, and how we got to this point. Let's talk about the container services. So generally speaking, if you are watching this, we assume general knowledge of our container service, the Elastic Container Service, which is our AWS native containerized, very simple container orchestrator, and the Kubernetes service, which is our Kubernetes optimized container orchestrator, right? Which we consider the best way to run Kubernetes in the cloud. Why did we launch MCP servers for an AWS service? Right? If these things, especially things like ECS, where we say it's very easy to use, what do we need an MCP server for? We believe that as generally Amazon does, that AI is transforming how people work and build and ship and observe their code. Now, AI-powered coding assistants are transforming developer productivity. And we believe that there is going to be effectively a new persona of user for our systems, right? The agents are not going to be generally very good at looking at our console. They weren't built for an agent to look at. They are good at using the CLI, but that doesn't mean that they optimally take advantage of everything that our APIs have to offer. They need an interface which is designed for them to extract the most out of our services, right? And AI tools lack real-time awareness. Let's imagine that a recent announcement that ECS launches ECS Express Mode. We launched that 2 weeks ago. That is very unlikely to be in an LLM's core set of databases. Now, we've set documentation up. We have documentation. These agents have the access to tool lookup, and so they can look up, and right, they can use web search, and they can go say, okay, the user is telling me there's something called Express Mode, and so let me go look up and let's see what Express Mode is, and I can list all the resources that Express Mode has, and I can discover, and it can funnel its way to a response. But there's two problems with that. Number one, generally speaking, LLMs do good with a very robust set of information. And so it's going to stick to what it knows, especially using older features, which maybe you all have spent time researching and writing and sharing about how to use ECS and EKS together. And so it has a wealth of data in its training set, which means that it's going to trust that, and it's going to be better equipped to use that, even if it can see the new feature. It may not know how to use it optimally, right? So that is a big problem that even the most sophisticated agents have, right? And so actually I should say there's also one other limitation, which is the ability to know exactly the way that AWS intends to use things. You all, through trial and error, and maybe through some very sophisticated UX guidance, we guide you into the experience of using our tools. But the agent doesn't really have that experience. It doesn't really have the ability to learn from trial and error in the same way that you do. And so we need a way to teach it and say, this is how you use it. So MCP has that opportunity to fix things, right? So because we are going to be able to give the agent updated, up to the minute, instead of using these APIs, use this set of APIs. We just launched them. Instead of using this deployment mechanism, use this one. We can also provide guidance for the user. We can do things like improve troubleshooting and improve operations, because we have a wealth of knowledge that would be very difficult for us to communicate to you, right? Nobody wants to read a 1,000-page manual on how to respond to every single thing that might ever go awry with one of the container orchestrators, right? Every single issue that you have, nobody has time to read that. The LLMs actually do a pretty good job of that if we give them the right mechanism to integrate with it. And so that's the opportunity that MCP servers have. So we started off building these, and we're going to explain how these work in detail. We started off shipping these locally, right? So there are two different kind of ways to improve or to use MCP. You can just run these locally. And so earlier this year, we launched MCP servers for AWS containers and serverless, so ECS, EKS, Finch, and Lambda. Each MCP server has its own unique set of tools, and we will describe more in detail about what all of these do. And they are available today to download, if you so want, from the GitHub repository, the AWS Labs GitHub repository, right? You run these things locally on your local machine. And they're a great way to get up started and testing. However, there are some limitations with running machines locally once you start running them at scale, right? And so to answer those and to talk more in detail about how exactly ECS and EKS GitHub, hosted MCP servers work, I'm going to pass it off to George, who is going to explain in detail about these. So George, take it away, please.
Right, thank you, Steve. So there are three main reasons, or four main reasons why we launched the hosted MCP server. I'll get into the details in a bit. But one of the main features the requests we have been getting is, especially the enterprises, they are not comfortable in getting their developers locally installing and running an MCP server. Their AppSec teams wanted to ensure that they had full visibility into what the users are doing When there is a zero-day vulnerability, they wanted full control of the ability to patch it. The other one was they wanted broader integration. So for example, we have a lot of third-party SaaS software as service providers who are kind of building AI agents. These need the ability to interact with EKS and ECS clusters, which again means that they need the ability to, they need a MCP server that's running and hosted in the cloud. And the last one here is that superior reliability and scalability that AWS has to offer. So 2 weeks ago, we launched the fully managed, remotely hosted MCP servers for both Amazon EKS and Amazon ECS. They're available in preview. In the rest of the presentation, I'll dive a little bit deeper into each of these. What are the capabilities it offers? How do you get started with those? It has also enabled a pretty cool feature in that you can now troubleshoot issues in the EKS and ECS consoles. We'll dive into that. And finally, we'll take a look at it. We'll look at it at a demo. I'll start with Amazon EKS MCP server. Before I dive into the details, I just want to give you a high-level idea of what are you able to achieve once you have configured your AI assistant or your AI tool with the MCP server. Essentially, you are able to use natural language to interact and manage your resources. For example, you can just type in your AI assistant. Let's say you're using Kiro, which is an AI coding IDE from AWS. And you can just type in, show me the status of my production EKS cluster. And it's not just limited to EKS resources. You're also able to manage and interact with Kubernetes resources, so pods, namespaces. So you could do things like show me all the pods that are not in a running state. Just type in natural language. You don't need the kubectl, which is the official Kubernetes CLI. You don't need to set up kubeconfig. Just type it, and you get the response. And we have also enabled the MCP server with tools that's going to help with troubleshooting. For example, let's say you have a pod stuck in a failed state. Just type that in, why is my Nginx ingress controller pod failing? And the last thing I want to call out is that these tools are not just read-only tools. These also enable you to create resources. Let's take a look at the request flow. Now, this applies to both Amazon EKS and ECS. So these hopefully hosted in the cloud. They are available in all commercial AWS regions. So this is available in preview in all regions except regions in China and GovCloud. And you can pick the region that you prefer depending on where your resources are. And let's say you have configured your MCP client. So MCP client here is an AI assistant, right? It could be Kiro Cursor client. It could be any MCP-compatible tool. And once you have set that up, and later on in the presentation, I'll show you how you can configure that. Once you set that up, the way the request reaches out or gets to the hosted MCP server, the hosted EKS or ECS, these are two separate MCP servers. They have separate endpoints. They're available in all the commercial regions. The way it gets to it is through a proxy in between. Now, the question is, why do you need a proxy? Now, both EKS and ECS MCP server are AWS services, and the way you authenticate to AWS services is through IAM. And the way IAM does authentication is through a mechanism called SIG-v4 signing. For that SIG-v4 signing, MCP protocol today doesn't support SIG-v4 natively. So you need this intermediary, which is now signing the request and then making a request to the hosted MCP. Once the request lands in the hosted MCP server, depending on the tool you're using, the appropriate downstream AWS service is invoked. I want to give you a concrete example now. I know it's a little bit hard to read. In the demo, I have kind of zoomed in, so you'll be able to see this better. But here I have Kiro, which is the AWS AI-powered coding assistant. Once you have configured your MCP server, on the left, this is just one-time step you do. All the tools listed out. So in the case of EKS, which is a screenshot here, there are 20 tools. They are all available to you. As a user, like Steve mentioned earlier, you are not directly interacting with the tools. These tools for LLMs, but it's always good to know about them. Once you have configured, you have done the one-time step, you can just type in natural language in the chat window, hey, in this case, it's asking, show me the status of a particular EKS cluster. The MCP client or the LLM knows about the tool called here, describe EKS resource, which would then kind of return the response. Just wanted to kind of give you a high-level view of what you're able to achieve with the MCP server. Now let's get into the details. The capabilities of MCP server can be kind of defined in terms of the tools we support. Now, and you can classify the tools we have into, in the case of EKS, there are 4 main categories. The first one is cluster management. These are tools that help with managing your EKS resource, like creating clusters, creating add-ons, deleting them. These tools some of these are read-only tools, meaning that, for example, the second one here is just doing a list operation, just listing all the EKS resource. There are tools like the first one, manage EKS stack, which is actually creating a cluster. You as a user don't really need to, you're not interacting with it, but it's always good to know. If you want to know more about it, our user guide covers the parameters it takes, which of those are required as such. The next set of tools we have are for the Kubernetes resource management. So previously we were talking about EKS resources. Now like Kubernetes resources, like pods, services. You can create them, delete them. There are tools for applying YAMLs. There are tools for generating manifests. The third set of tools are documentation and troubleshooting. I want to spend a little bit more time here. So Steve earlier mentioned like let me take a step back. So initially when we launched the open source or the version of MCP server, we did not have search EKS documentation. And what we found out during the development was the knowledge gap that Steve was mentioning. Any LLM version, if you go to the particular version, if you look at the documentation, they say there's a knowledge cutoff date. Basically, that is the date on which that LLM was trained on. So if there is a feature that came out after the knowledge cutoff date, it's not really trained on. It might be able to use tools and still get information, but it's not really trained on that. And we were finding gaps when we were trying to troubleshoot newer EKS features. We found that the LLMs were not really doing a good job. Hence, we built this tool. What this tool does is that in the backend, it is connected to an index of all AWS documentation. So all AWS documentation, all AWS What's New posts, all AWS blog posts are kind of indexed there. And this tool is able to kind of reach out to the index and retrieve the information. So now you're augmenting the LLM with some of the missing information through this tool. So that's the first tool. And second one is EKS troubleshooting guide. So this is actually a knowledge base we are hosting in the cloud. What this knowledge base is pretty much a distillation of all the knowledge we have gained managing millions of Kubernetes clusters. So over the years, we have been managing a lot of Kubernetes clusters. There are a lot of runbooks we have internally. And some of these are, these are all runbooks that are externally, can be shared and are useful. Now, all these runbooks have been added to this knowledge base, and this particular tool is actually reaching out to the knowledge base so that you're now augmenting LLM with various runbooks that it can use for troubleshooting. This set of tools is related to troubleshooting. So if you usually look at any troubleshooting runbook, one of the first two steps is to get more telemetry, right? Getting more metrics, getting more events, getting more logs. So these tools are kind of providing those needed telemetry back into LLM so that it can effectively troubleshoot an issue. And then we have a couple of tools for security. This was kind of introduced because we noticed a lot of the times the issues are related to IAM permissions or the lack of it. So this tool kind of helps with that. All right, so now we looked at the capabilities. Let's take a look at some of the prerequisites, right? So like I said before, EKS and ECS, and we'll dive into ECS a little bit later. EKS MCP server, it's protected by SIG v4, it's protected by IAM, so there are certain permissions that you need to set up. The two key permissions are EKS invoke MCP. This is what allows so the IAM identity, whether it's an IAM user or IAM role, that you're using to connect to the hosted MCP server endpoint needs to have invoke MCP permission. That is what is allowing the MCP client to do a list call to understand about all the tools that are available. Then we have another permission called call read-only tools. And this is kind of granting access to the read-only tools. So if you recall before, I said that some of the tools are only doing read-only actions, like getting or listing a resource. But then there are a bunch of tools that are actually mutating, like creating a cluster or creating a pod. So this tool, this permission is ensuring that only read-only tools have permissions. And the last one is call privilege tools. If you want to allow all tools to be able to connect to your MCP server, then you also need to have call privilege tool. So one thing I want to really call out and I want to emphasize is that, especially in production, start just with the read-only tools. LLMs have their own intelligence, right? Most of the time they do a good job. Sometimes they can hallucinate. I've been in scenarios where it inadvertently goes and deletes resources, and which I didn't want them to do. So definitely start with just invoke MCP and call read-only, at least in production. You can use call privilege tool in your dev environment or test environment, but I would say start with the first two. So those are the three permissions that are required to connect to the MCP server. But once you connect to the MCP server, there are a bunch of tools. So if you recall, there were tools to reach out to CloudWatch to get logs. So you need additional permissions that you need to configure on your IAM identity. Now, we have a managed policy called EKS MCP read-only access. So if you go into your IAM console, search for policies, just type that word, you can see the full, like this pre-can policy available to you. It has the full list of permissions that all the read-only tools need. For write tools, we don't have a pre-can policy today, but it's kind of it's listed in the EKS user guide if you want to learn more about the permissions. All right, so we looked at what are all the permissions you need to configure on the IAM principle that you're using to connect to the MCP server endpoint. Now let's talk about the proxy. I kind of covered it a little bit earlier. Proxy is what that is kind of the intermediary between the MCP client and MCP server, which is doing the SIG v4 signing on your behalf, or on behalf of the request. The proxy is available in that GitHub repo if you want to take a look at it. The proxy is also available in the Python package index, so it's very simple to install. You can use UVX to install it. The good thing is that this proxy is required to connect with any AWS first-party hosted MCP server, not just EKS and ECS. There are many other MCP servers remotely hosted that are coming out. So you need to run this proxy, but you just need to run it one time. And then you can have different blocks to connect to the different AWS hosted MCP servers that you're interested in. What are some of the other configurations? The first one is profile. So the MCP proxy is doing SIG v4 signing. And to do the signing, it needs credentials. And it picks up the credentials from the profile you specify here. I'm referring to the AWS profile. So depending on which profile you specify, it uses those credentials to sign the request to connect to the the hosted MCP server. A couple of other interesting things you should be aware of is the regional endpoint. So like I mentioned, the remotely hosted MCP server is available in all commercial regions. In this case, I'm connecting to our Oregon region, so you would use US/West 2. And the service here is EKS MCP. This is an important call out. Like I said, there are two ways in which you can ensure that the LLM doesn't take actions that you don't want it to do, especially mutating kind of actions. So one is IAM. Like I said, when you create the IAM permissions, make sure you don't have the call privilege tool. The second one is if you specify a read-only argument here, the MCP client gets access to only the read-only tools and not all the tools. Now, so I was talking so far about EKS. Now let's jump to ECS. A lot of what I said also applies to ECS, but let's take a deeper look. ECS again enables you, ECS MCP server enables you to use natural language to manage ECS resources. And these are just examples. This is much broader than that, but just to give you an idea, you can do deployment monitoring. You're able to investigate the health of containers or tasks. You're able to troubleshoot issues, and you're also able to look at things like network configurations. ECS classifies the tools into three kind of broad buckets. The first one is operational tools. There are a bunch of tools that helps you with doing things like getting the status of your deployments or fetching network configurations. These are kind of very critical when you're trying to troubleshoot issues. You have tools for resource management. There are tools for tasks, like getting more details about task definitions. You also have tools for troubleshooting. I think ECS has done a really good job at really pinpointing on what are the biggest pain points that customers have, and we have come up with tools that is helping with troubleshooting some of the most common issues that I've seen. In terms of permissions, there's a key difference between EKS MCP server and ECS. All of ECS MCP servers are read-only tools, so you don't see the third call privilege tool kind of permission. But these are the two key permissions you need to configure on your IAM principle that you're using to connect to the ECS MCP server endpoint. There are, if you recall, some of these tools like fetch network configuration is actually making call to EC2 APIs. A bunch of the tools are calling ECS API. So there are additional permissions that you need to configure on your IAM identity. You can learn more about it in the user guide if you're interested in seeing what those are. Same thing like EKS, you need to run that MCP proxy. You don't need to run it multiple times. You can just have an additional block. Let's say you have a scenario where you need to connect with both EKS and ECS MCP server. You can just have an additional block that is now pointing to ECS instead. The key difference between EKS and ECS, if you look at the endpoint here, it starts with ECS. So this ECS, similar to EKS, as a regional endpoint. So you connect point to the appropriate ECS regional endpoint. The service here would be ECS MCP, and the profile is where it picks up the credentials to do the SIG-V4 signing. All right, so now switching gears a little bit, one of the cool things that we have been able to do with the MCP server is really improve the troubleshooting experience in console, both EKS and ECS. In the demo, I'll kind of give you you'll get a better understanding, but just to kind of quickly walk over it. Anytime or a lot of places where we surface up an issue, an error in the EKS or ECS AWS management console, now you can see in context an inspect with Amazon Q button. So what we have done is we have integrated with Amazon Q and the MCP server tools to quickly help you triage or root cause issues and also give you recommendations of how you can go and resolve it. Just to give you an idea, I don't know how much of this is visible, but just at a high level, these are some of the various points in the EKS console where you have this inspect with Amazon Q integration. So for example, if you go to the observability dashboard, there are various kind of health issues for the cluster health issues we surface up. Now you would see there's an inspect with Amazon. So if you click on it, you have an Amazon Q chat panel open up and where you can go triage and resolve the issue. Similarly, you have other points like upgrade insights or control plane monitoring and node health issues where this integration is available. In the ECS console, similarly, there are multiple points in ECS console where you are able to leverage this integration. For example, here I'm showing the deployment. So this deployment is rollback. So you have, when you click on that status saying rollback successful, if you click on it, you have an inspect with Amazon Q button that you can integrate and learn more about what was the reason and how you can go mitigate it. Similarly, for task failures, you can click on the status and you have that integration available. So before we talked about, we saw how the request flow to connect to the hosted MCP server. Now with this Q integration, you also have another flow. From the console, you are able to kind of troubleshoot various issues, an AI-powered experience for troubleshooting, which is in the backend using the various tools provided by EKS and ECS MCP server. All right, with that, let me move to the demo. So this is a recording I took a couple of days ago with LLMs and hallucination. I want to make sure we have something decent to show here. So it's a recording, but it's real. I'm going to start with I have two main sections in the demo. The first one is the hosted MCP server, and for that I'm going to use EKS. But ECS is going to be very similar in terms of the capabilities and what you can do. And the second part of the demo, I'm going to show you the troubleshooting experience in console, and for that I'm going to be using Amazon ECS. So we'll start with the prerequisites. If you remember, I said there are two things you have to do. The first one is you need to configure your IAM identity with the right permission so that you can connect to the remotely hosted MCP endpoint. So we'll take a look at that first. And the second one is configuring an MCP client. So here I'm using Kiro, which is the AWS AI-powered IDE. You need to configure it one time so that the Kiro can connect to the MCP server. So those are the two prerequisites. Let's take a look at that first. All right, so I'm in the IAM console. Let's go to the policy. So I mentioned earlier there is a pre-can managed policy called Amazon EKS MCP read-only access. So if you click on JSON, you can see the full set of permissions that are required by all the tools. So these are all the read-only permissions that are required. And at the bottom, you can see the two key permissions I mentioned that are required to connect to the EKS MCP server, the hosted endpoint. So invoke MCP and call read-only tool. And above that, you can see all the other permissions. So these tools are making a bunch of calls to, like, for some of the tools are making calls to EC2, some of them are calling to CloudWatch, some are calling to the STS. So you can see the full set of permissions that the tools need. They're all listed out here. Now, for the demo today, I'm going to be using both read and write tools. So let me go ahead and create a new policy. So I'm using the console here. So you can create a policy. You can click on JSON, where you now have the ability to fill in the policy. Now it doesn't have anything. So I'm going to switch to the user guide, the EKS user guide, under Tools, MCP Protocol. This particular page on step 3, the full set of permissions that you need for both read and write is listed out here. So just for reference, these are all the permissions the tools need. So you can copy that into you can use that to create your IAM policy. And like I mentioned before, you can see some of the key three permissions that are required for EKS MCP at the bottom. All right, so now let's go ahead and click next. I'm going to name it EKS-MCP server, MCP server write policy. You can verify all the permissions look good, and you can hit create policy. So now you have created the policy. Now we need to attach this policy to an IAM principal. For the sake of simplicity of this demo, I'm just going to create an IAM user. So I'm going to create a new IAM user. And our goal is to now attach the previously created policy to this user. So I'm going to call it EKS MCP server user. Now we need to locate the policy that we created in the previous step. Just search for MCP, and you see it at the bottom. Select it. And click next. If everything looks good, you can create it. So now we have the user created. Now we need to create an access key, secret key for this particular user. So we can go into the particular user, go to Security Credentials tab, and you can create access key, secret key for this particular user. And what you're doing is once you have created these credentials, you're copying it over to your local machine, the machine where you have the MCP client set up. So in my case, I'm using a MacBook, so I'm copying the access key, secret key to my local machine, and I'm going to be setting that as the AWS profile. So here I'm using Kiro IDE. So we have done with the first step of the prerequisite of creating the IAM permission. So we have done that. The next step, the next one-time step you have to do is now configure your AI coding assistant to connect to the MCP server. Here I'm using the AI coding assistant or MCP client that I'm using is Kiro. So if you go to Kiro, you can see that I do not have any MCP servers configured right now. So you can click Open MCP Server Config. As you can see, there are no MCP servers. If you go to the EKS user guide, we have instructions for Mac and Windows. Since I'm on MacBook, I'm going to copy the Mac section here. And all these applies to ECS as well. I'm just showing, in the interest of time, I'm just showing it for EKS today. So you copy it over. You can see the proxy. I'm going to connect to the Oregon region. So I'm going to update the region to be US-West-2, since that's the Oregon region endpoint. And my profile, if you recall, even though I did not show it in the demo, I have a profile called demo-profile that has the access key and secret key that was created previously. So I'm updating to use that profile, and I update the region to US West 2. Now when I hit save, notice on the left side, you can see the MCP, the Kiro is trying to connect to the remotely hosted MCP server. It takes a few seconds. It's doing a SIG-V4 signing, and it's connecting to it, making sure I have the appropriate permissions. And once it does that, you can see that it has found 20 tools. There are 20 EKS MCP server tools. All of them are listed here. As a user, you would not be directly calling them, but it's good to know. You can hover over them, and you can see detailed description. But these are also available in the EKS user guide if you want to learn more about these. All right. Now we have done both the steps, right? We created the IAM permissions, step 1. Now we have configured my MCP client, which is Kiro, to connect with the MCP server. Now let's start using it. So I'm going to let's start with something simple, right? Let's start with, show me the status of my clusters. So I'm going to open the chat window in Kiro. And then I'm going to just type in the prompt, show me all EKS clusters and their status. So I have 4 EKS clusters in my environment. So Kiro automatically detects that there is an MCP server. Based on the tool description, it figures out that there is a tool called list EKS resources, which looks like the right tool to get more details about the clusters. And actually, it's also listed on the left side. If you see there's list EKS resources, one of the tools there. And then I've set up Kiro in a way that I'm not auto-approving. You have the option to say, hey, auto-approve all tool calls. Especially when you're getting started, it's good to individually approve and make sure it is calling tools that you understand and the tools that you wanted to invoke. So I approve this request. So it's calling a few other tools. So it found out there are 4 clusters. It's doing a describe call for each of these. And in the end, what it returns is, it gives me a status about the 4 EKS clusters. It gives information about the status of each one of them, the version, when it was created, the region, all that information. So it was so easy. I didn't even have to set up kubectl. I didn't set up AWS CLI. Only thing I needed was AWS profile, the IAM permissions, and the MCP server configuration I showed you. With that, and just in natural language, you are able to now interact and manage your EKS cluster. So this is a very simple case. Let's try another one. The next one is, what I want to show is I'm going into one of those clusters, which is the second one here, EKS ECR cluster. Now that is on Kubernetes version 131. If you have worked with Kubernetes, you know version upgrades is it's a little bit of a scary thing. Kubernetes doesn't support rollback of versions. So before you decide to upgrade to a version, you want to make sure things all look good, that things doesn't break. So what I'm going to do is that particular version 131 is not the latest. We are right. The latest version is 134. So I'm trying to migrate from 131 to 132. But before that, I just want to see, hey, am I ready? Am I good to go ahead and hit the upgrade button? So my prompt, if you read the prompt at the bottom, is saying, assess my EKS ECR test cluster, it's upgrade readiness, including support status, upgrade timelines, and identify any blocking issues. That's all what I entered, and I hit enter. Now, Kiro now figures out that there are tools within the 20 tools that MCP server supports, which helps with this scenario. There are tools like Insights, which gives information about the upgrade readiness. So Kiro is actually thinking through it. It's actually making a bunch of calls. So it found something. It's doing a list EKS resource, trying to learn more about the resource it found. Let's just give it a few seconds here for it to complete its information gathering. And finally, it generates a report here, right? I'll kind of scroll back up. I'll just finish it complete. I'll let it finish. So what it really, so it's giving me this report, right? It identified one blocking issue. It's saying that one of the add-ons that I have running on my cluster called AWS Guard Duty Agent is on a version that's incompatible with the version I'm trying to upgrade to. So it's kind of flagging that for me, saying, hey, you have to go fix that. If you don't fix it and you upgrade it, your cluster is going to be in a broken state. And then after that, it kind of has a bunch of checks that all looks good. It has a few other checks, which queue proxies, queue cluster health issues, all that succeeded. And finally, it's giving me a recommendation of the steps I have to do before I hit the upgrade button. All right. So let's do another one here, which is creating a new cluster. I don't know how many of you have created a cluster either using AWS CLI or EKS. Cuddle. EKS cluster creation involves a few steps, right? There are a bunch of prerequisites you have to create. You have to create VPC, you have to create subnets, and then after creating them, you have to pass those to create cluster call. There's a lot of work you need to do today to create cluster. But here you can see that with just a simple text line, I'm just saying create a new EKS cluster, and that's it. And it figures out all the dependencies. It uses CloudFormation behind the scenes to create the cluster. Now, you might not create production clusters using this, but this is like if you have an idea, you want to quickly try out, you want to quickly create a cluster, this is a great way to get started here. And even though this particular tool is using CloudFormation behind the scenes, you can use other tools. Let's say if you want to use Terraform, you can always, as long as you're prompting in the prompt, it's okay, create a new EKS cluster with Terraform, LLMs usually respect what you have specified. But if you don't specify anything, by default, it uses the tool which uses CloudFormation at the backend. So there is a tool called Manage EKS Stacks. You can actually go to CloudFormation. You can see that particular template that's being used here. And so it creates a template, and then it goes ahead and starts deploying the template. Now, creating a cluster still takes around 15 to 20 minutes, so it's going to take a while. But at least it gives you so here you can see that it started that process of creating the cluster and all the configurations associated with the cluster. All right, so I'm not going to wait for that. Let's move to the next and the last scenario here. This is a troubleshooting scenario. So here I have a cluster called MCP demo cluster, which has a load balancer, which is kind of in a broken state. This load balancer service, it's a service object in Kubernetes. It is in a pending state. It's not able to get external IPs. So I'm just typing in natural language. I'm asking it, hey, my load balancer is in the default namespace, or my cluster MCP demo cluster is stuck in pending state. It's not getting an external IP. Can you help troubleshoot? This is where some of the troubleshooting runbooks and the troubleshooting tools I was mentioning to you previously are being used now. So let's see what Kiro does here. So Kiro calls the EKS troubleshooting guide. So Kiro is actually, it knows that there is a tool which is called troubleshooting guide. It passes this error message as part of a query parameter to that particular tool. And it's trying to see, is there a runbook that's going to help me with that issue? It kind of goes through that cycle a couple of times. Then it finds out that there is an issue with the service object, so it's making another call, read Kubernetes resource to learn more about a service object. Then it tries to get the events associated with the service, because obviously there is a failure. It's trying to understand. So it's kind of doing its own information gathering here, calling multiple tools. It's looking at the runbook. It's following through the steps that are defined in the runbook and trying to figure out the root cause. Let's give it a couple more seconds here. OK, so it figured out the root cause here, and it's also giving steps to fix. I'll scroll back up to kind of give you a second to read that. But so the main issue it found out was that one of the subnets that are associated with that particular load balancer did not have the appropriate Kubernetes tags associated with it. So it's saying those tags are missing, and it's also giving us steps to go ahead and how you can go fix and resolve the issue. All right, so that was the last demo from the hosted MCP servers. I was just using EKS. Like I said, all of these capabilities or similar capabilities are available on ECS as well. You would be following the same steps in terms of setting up, including IAM permission setup, the MCP configuration. Now I'm going to switch gears, and let's take a look at the troubleshooting experience we have enabled in the AWS console. For this, I'm going to be focusing on the ECS scenarios and how we are kind of enabling troubleshooting there. So here you have a particular cluster which is stuck in delete in progress state. This particular task definition is stuck. And if you have noticed before, there was an inspect with Amazon Q button. Let me see if I can just go back a little bit to show that. So this is a new this button is something new that we introduced. So now when you click on the status message, you have this inspect with Amazon Q. And that is the integration we have done with Amazon Q developer in the console. When you click on it, it automatically opens up the Q chat panel on the right side. And it's pre-populated with a prompt having context about the issue and everything that Amazon Q developer needs to go resolve and go figure out and troubleshoot the issue. So here you can say Amazon Q is now kind of calling it. Amazon Q has its own sets of tools that it uses behind the scenes, including the tools that are available from EKS and ECS MCP server. And it kind of lists out the root cause. So the root cause here was that the tool is being used by running ECS service. And it not only points to the root cause, but it also gives you steps of how you can go recommend it. One of the good things is that it is not automatically mitigating it. It's giving you the flexibility so that you can read through it. If you think this is the right way to resolve it, you can go and take the mitigation. All right, so yeah, that is the rest of the report here. So moving on to the next scenario. So here you have a task that is stuck in a stop state. And the failure is that it's not able to pull a container image. Again, like I mentioned, if you click on the stop status message, you now have this new enhancement where we have the inspect with Amazon Q. So now if you click on it, it automatically opens up on the right side the Amazon Q chat panel. And it has a prompt pre-populated with the context so that Amazon Q developer can now go and troubleshoot the issue. So Amazon Q developer is now kind of calling various tools, including some of the ECS tools. It's trying to learn more about the task definition. It's trying to get the task health data. Amazon Q developer also has a knowledge base. So it's retrieving knowledge. And here you can see in between, actually, the calls failed. So it automatically retries. So trying to find the service status, it failed a couple of times, but the third try, it succeeded. And finally, it was able to get to the root cause. So the root cause was related to, I believe, network configuration here. It's kind of listing out the factors that contributed to that. And then later on, it also shows you how you can go resolve it. Cool. So that was the second scenario I wanted to show in terms of troubleshooting experience you have in the ECS console. All right, that brings us to the end of demo and the end of the presentation. Thank you all for your time. Really appreciate it. Thank you.